Hello, Oslo. Hello. Welcome. I'm going to talk to you today about computer vision, machine learning, data science, and artificial intelligence. How many people are doing any of those things right now? Looks like maybe about 10 hands went up of the 400 or 500 people in the audience. Are you guys making a lot of money doing that? You are, aren't you? They are. It's a hot field, every one of those things. Those of you that didn't raise your hands, try this experiment. Add the words machine learning to your LinkedIn profile and watch the recruiter spam go up exponentially. It is a hot topic right now. But it's not something you just fall into. It's not something, there's some challenges to it. To do any kind of machine learning, any kind of artificial intelligence, you typically need a lot of data and a lot of time and a lot of compute power. And most of us have none of those things. But Microsoft does. Microsoft has Microsoft Azure, our cloud platform. Data centers all over the world, huge amounts of compute power, and we've done a lot of that machine learning for you. My name is David. I work for Microsoft. Actually, my title just changed. I'm a software engineer. That's what I am. And I'm going to talk to you about a set of tools called cognitive services that allow you to take advantage of machine learning that's already been done for you. Most of these tools are just simple web service calls. You can pass it a picture or some text or some sound, and it'll return information about that because it's already crunched through some of these machine learning algorithms to give you information about what's in the picture or who's in the picture, or what is the recognized speech recognition, optical character recognition, sentiment analysis. There's all sorts of services that are available inside of these cognitive services, and they're free. There's a free version of them. You can get a paid version, which will give you more capacity, but you can get started for free at this link at the top here, microsoft.com/cognitive-services. Now, there are dozens of cognitive services. We're going to focus on the Vision API here. In fact, we're going to drill down into the Vision API and focus on these parts of the Vision API: custom computer vision, face API, and the custom vision service, mostly the custom vision service. So the simple one, I'll go through this really fast because the talk is really about some of the more complicated parts of this. The really simple one is the face API. Face API, all you need to do is to send an image to a web service. Post an image to a URL that looks something like this: https://something.api.cognitive@microsoft.com. You can copy that out of the documentation, post an image to it, and it will return some JSON. JSON is just a standard format for sending data across the internet. It's nice and compact, and it'll return information like it'll find all the faces in the picture, and it'll tell you information about those faces, like where's the outline of the face, what are the coordinates of the outline, what's the age of each person, what's the gender of each person, do they have facial hair, or what kind of glasses are they wearing, if any, are they happy, are they sad, are they angry? All sorts of information can come back from this, just with a simple web service call. It can also detect if it's a famous person. So if you pass it a picture of who's a famous Norwegian, I'm not from around here. No? Ole Amundsen. He's a famous Norwegian, isn't he? Anyway, pass the picture of a famous person, it'll tell you that, oh, it's that famous person, and it'll return that information, usually with a confidence level. I'm 86% sure that's Ole Amundsen. But if you pass it a picture of me, then it probably wouldn't recognize me because I'm not famous yet. But I can train it. And I can train it without doing this tons of machine learning algorithms, without writing a lot of code to do this. I can train it by sending it images of myself to web service calls. So simple web service calls allow me to do custom image detection. So for example, if I wanted to train it to recognize anybody on my team, or anybody in my company, or anybody in my family, maybe I want to do this for authentication purposes, then I can say, send it pictures of the people in my company and tag those people so it knows who they are, and then go through some machine learning training. Again, it's a simple web service call. Then it will recognize via a picture, by a new picture, the people that are on my team, because it's been able to be trained on that. And these are the steps for doing that. Create a person group. There's this concept of person groups, which would be the team or the company or the family or the organization, however you want to group them together. You add people to that, and then you add pictures to those people, And then you train that whole person group, and now you have a predictive model such that if I send a new picture to this model, using this model, it can predict with some reliability which one of those people that's a picture of, or that it's not somebody that recognizes it, it's not in that group. So here's a little picture of that. The concept of a person group is just an organizational unit, and within that unit we have one or more persons, and within each person we would add pictures of that person, and then we would train that and create our predictive model. So an example is if I had a company X would be my person group within that, and I create it just by calling this web service. One web service call, pass in a parameter, in this case company X is part of the URL, and it'll create a person group. And then within that person group, I can create a bunch of persons, which is another web service call. So if I have 3 persons, that would be 3 web service calls. And then I would add pictures to each one of those persons. And each one of these pictures would be a web service call, which would include in the body an image. And then I would train it. And I would, let me see, here we go. Train it. And training it is just, again, a web service call. We call this, post to this URL, and it will train the image. And then I have a predictive model, and I can take it and say a picture of Jack. Here's a picture of my Uncle Jack here. Post that to a predictive URL, and it will return information. Hey, that's Jack. I recognize him. Or, it's a little bit more than that. It'll say, this is Jack, and I'm 82.35% sure that it's Jack. Or this is not anybody that I recognize among all the people in your organization. So these are the steps here. Here's your little cheat sheet. I'll make these slides available to you, but to create a person group, you would use an HTTP put to a URL that looks kind of like that. To create persons, you use a post to a URL that looks like this, and then add photos as a post to that URL, training it as a post to that, and then finally, when you identify the face, you will post to something that identifies this whole person group. All right, that's the overview. I'll show it to you in action here. All right, make sure we can see. Yes, okay. So what I'm going to do, to get started with this, you do need Microsoft Azure. You need an Azure account. And, or fix apps that are, no, I don't want that. Get out of here. So if you go to azure.com, you can get a free Azure account. I think it gives you a 30-day trial and gives you like $200 or something like that. These are really cheap. So you can use the free version or you could use the cheap version. The cheap version, I think, is you get like 10 calls per penny or something like that. So I come in here and I have an Azure account already. And I can create a cognitive services account very quickly. When you log into the Azure portal, the way that you create anything in Azure is with this big green plus button up here. Click on that, and from here I can create, under AI and machine learning, I have all of these cognitive services things, including my Face API. I'll just go in here and click on Face and fill out this really brief form. I'll call this one Test NDC Face. How about that? I'll put it in North Europe because that way there'll be less latency here. Do I want to use the free one or do I want to use the cheap one? I might be limited. The thing you get with the non-free one is you get more calls per minute and more calls per month. So I'll do that one. It's still really cheap. And then I'll create a resource group, which is just a way of grouping together resources within Azure. So I'll call that one Test NDC RG for resource group. And then this takes less than 30 seconds. It will create a Face API for me. And the 2 pieces of information that it'll give me are an API key, which is just a long string of letters and numbers, about 20 characters long, that I'm going to pass with every web service. And that way it knows that it's me. It knows whether I've exceeded that 20 calls per minute or if it has to charge me 1/10 of a penny each time. It knows that. And the other piece it gives me, let me go actually open the resource, is a URL. And the URL will vary depending upon where I put this. I actually said put it in Northern Europe, so Northern Europe will be part of the URL. So here it is. Here's the keys right here. And you see there's 2 of them. Either one will work. The reason there are 2 is in case one of them gets compromised, you can regenerate that one and fail over and start using the other one. There's really no difference between the 2. I'm going to actually copy that and paste it into a text file right here, right there. There's my key. And then if I go to overview, right there is my URL. Grab that right here. and paste that in right there, just so I have it for later on. Now I'm going to jump over to Microsoft.com/cognitive is a shortcut to get to Microsoft. This long URL here. And here we see we've got all sorts of things in cognitive services that I'm not going to talk about. They're really fun to look at. I'd encourage you to look at them later. But I'm going to focus on vision right here. And that's where we have the computer vision API and the face API. I'll open up face API in a new tab, and I'll open up computer vision in this tab. If I click over here on face API, you'll see nice samples about how to use face API. So for example, if I sit at this picture right here, there's one face in it, and here's the JSON that came back from it. That bracket means it's an array of faces, even though there's only one, and then it has information about, there's the type of hair this person had, brown hair, whether they're smiling, it's a female, she's about 24 years old, all sorts of information like that. Here's one with two faces, two happy people. And what's that? Oh, I don't know what that is. Click on that. Please make sure the file being provided is below 4 megabytes. That's a weird error. Let's do that again. It's your file. Give me this. Let me refresh. All right, back to here. This is a good time for a quick review. And here we go. All right, so I'll try this one more time. There's 3 faces right here. And there we go. Okay, so I'm on, and it came up, and they've written a little JavaScript here, so it'll outline the faces because that's part of the information that was returned. And if I hover over it, it tells me gender, age, glasses, emotion, and things like that, which is pretty cool. If I go over here to the image, the computer vision one, you can see this picture right here. The important thing it gives is, the text, the caption. People waiting at a train station. That's pretty good. That actually is what it is. And it told me it's 83% confident. A lot of the information actually gives you a confidence level. This one right here, the caption is, a young man riding a skateboard, 81% sure that that's it. So it's doing a pretty good job of figuring out what these things are. And then down below, we see the celebrities right here. Here's a celebrity. Who knows who that celebrity is? Does anybody else shout it out? Satya, that's right. That is Satya Nadella, my boss's boss. Yes, that's who that is. And here you can see it right here. This Satya Nadella. I think it says 86% is sure that it's him. I want to bump that up. Whoever wrote that, that's because your job's in jeopardy if you're not at least 100% sure who Satya is and you work for this website. All right. So how do we work with this? Let me go back to here, and up at the top is the API reference. I think there's a lot of software developers in the audience, and you're interested in APIs. What's the details of how to call this? And that's what's on this page right here. And there's all sorts of things you're going to do. So the real simple one that I just showed you that just detects faces and returns information about those faces, that's this right here, face detect. Click on that. It'll show you that API. And you can see that it is a post to this URL, https:// some location. I selected North Europe, so that would be the location. So northeurope.api.cognitive.microsoft.com/face/v10, etc. That's actually this URL right here that I got out of that. And then because this is face detection, it adds /detect here, and then there's some query string parameters like afterwards, like return face ID and return face landmark, face attributes, and those are all described right here. Do I want to get the face ID back because maybe I want to call it again and get more information about the same picture? Do I want to return the landmarks like the outline of the eyes and nose and mouth if I want to do a face swapping out, things like that. All that's described in here. Here's the headers. This is where I pass in my key, this key right here that I got from Azure. And this is where I pass in the content type is how am I going to send the image? There's 2 ways to send an image. One is I can send it a URL that points to an image on the web, somewhere on the public web, in which case I'd say content type is application JSON, and I would send the URL like this as a simple JSON. The other way I could do it is I would set the content type to application octet stream, and in that case I would actually send the binary image itself. So if I had a phone app, maybe I would take a picture and send that off to the web service. Either one of those will work, just have to be consistent. And that's it. That's the entire call right there. When I call it, I'll get a response back. This is HTTP, so the way that we know that it works is if we get a 200 response, that's the OK, the all good code from HTTP. And if that works, then this is the data I'll get back: the face ID, the face rectangle, the face landmarks, all that stuff back. And here's an example of how it'll look. So this is pretty simple to code to. It's just simple JSON. And if you're still confused by that, way down at the bottom is sample code in C# or Java or JavaScript or Objective-C or PHP. Really, anything that can make an HTTP call can call these services. It's just REST and JSON. It's all standards. So I can copy and paste this code and give it to my boss and pretend like I wrote it and build it into my apps. It's pretty cool. If an error occurs, this part up here is just describing potential errors. Like 401 probably means that you got the key where you gave it the wrong key, or things like your 403 means that you tried the free version, but you tried doing more than 20 calls a minute, something like that. So these are possible errors, and you usually get a descriptive error back as well. All right, so that's the simple one. The one we want to do is the custom vision, and that's also under here, under face. Let's see. Here's where I create, remember I said you create a person group, and then you add persons to that person group, and then you add images to the person, and then you train it. Those are the steps. Well, here's how to manage a person group. If I wanted to create a person or delete a person or get a particular person based on its ID or get a list of all, not persons, person groups, that's all in here. So for example, if I wanted to create a person group, here's the documentation for doing that. Again, it is a simple web service call. Right here, it'll be a put to this URL right here, and at the end, the parameter will be the ID of the person group I want to create. And that's just described here in the documentation. The same header information. Content type is actually, the content type is, there's only one, it's application JSON, so you don't have to worry about that. But the key is important. You have to pass in your correct key. And I call that. And I can even see this in action. These buttons up here, they'll open up a little test harness. So if I wanted to go to North Europe, then it'll open up a page where I can actually test this web service call and say, I'll give it a group, I'll call it NDC group right there. And for the key value, this key, I'll copy that and paste that in here. And that's pretty simple. And this is all the name and the metadata about that, that's all optional. I don't really need that. I can overwrite it if I want to. Click send. Oh, it's bad. What's wrong with it? Response latency. Person group ID is invalid. Person group ID, let's do this. Test NDC1. How about that? I might have used that one earlier. That's probably why. So click on send, and now that's OK. So whatever I was doing wrong before, I fixed. And so I got it back, and I could, for example, let's see. Let me go back to the person group and do this list right here. And the list, here's the parameters of how to do it, but it's pretty self-explanatory. I'll open up the test harness, paste in my key. All the parameters are optional. I don't worry about it. And I got a list, and you can see the list is it's an array of the one person group that I've created right here. So this is just how we make these web service calls. And if I wanted to, I can go through this test harness and add persons to the person group and so on, but I've actually written some code to do that, which is right here. No, it's not. It's right here. Thank you, do that, I'll actually show you it in action. This is what the code does, and then I'll show you the code. So right here, I'm going to create a group. I'm using a different account now, so my group that I just created isn't on there. And I'll say, I'll call it DG test NDC. I always name my demos DG, my initials, followed by test. So I'm going to create a person group called DG test NDC. Click on that, and that's just called a web service, the same one I called before. And this list right here, called the other web service, to get a list of them all. And in here, I'll add people to that group. So I'll add a person called David. Click that button. That called a web service. And you can see it returns information. It returned a GUID. That's the person ID that it assigned. And I'll add 3 people to this. I'll add Brian, and I'll add Jennifer. So Brian and Jennifer are old friends of mine, and I happen to have a lot of photos of them. That's why I picked them. And then, so I clicked that 3 times. It the code I wrote called a web service 3 times, and what I'll do is I'll add pictures to each one of these persons. So I'll go here, and I've got pictures of myself on my computer, like you do, right? There I am, whole bunch of pictures of me. Click Add Faces to Person, and I think there were about 10 pictures, so it's going to call a web service 10 times. It's going to pass in this GUID to indicate that it's David, and it's also going to pass the image, and it returns some information that I'm outputting here. So I'll do that for David. I'll do that for Jennifer. I've got pictures of her on here. Jennifer, all right. And add my 8 or so pictures of Jennifer. I think Jennifer has spoken here, I'm pretty sure. Not sure if Brian has. And there's my Brian pictures. All right, so add faces to Brian. Make sure I got the right one. So each one of these is a web service call, and when it's done, it'll tell me, okay, 12 faces added. So now I'm done. I've just added about 30 pictures for these 3 persons, and all I have to do now is train it. Click on this train right here. That'll call a web service, and the training sometimes can take a long time. If you have thousands and thousands of pictures, that might take a long time. I only had 30, so it went really quickly. But because it can take a long time, it doesn't return the status. It just says started, and there's a different web service to call just to make sure it's done. It is done. It was done in like a fraction of a second. But now it has these pictures. It's been trained. I've got a predictive model that says, I know what Brian looks like. I know what David looks like. I know what Jennifer looks like. I can now give it another picture of one of those 3 people, like right here. I have a picture that wasn't in my training set. Right here, here's a picture of me right there. And if I click Identify Faces, it should come back and say 1 face detected, and it's 82% sure that it's David. And because I get the rectangle, I put the label right there in the corner of that face, which is useful. Here, let's do Jennifer, because even though I'm better looking than Jennifer, she's way smarter than me, right? And so 81% sure here, but the labels is kind of nice because if I have a picture of more than one person, like I have here, I couldn't find a picture of all of us together, so I just made one. Then there's Brian, there's me, there's Jennifer, and there's Kevin, who I didn't train on Kevin. So it found 4 faces, and it was able to match David, Jennifer, and Brian with pretty high degree of confidence. I could use this for, finding people in a crowd, or, let's say I had missing children I'm looking for. They're not famous people that are missing, but I could, if I have a lot of pictures of them, then I could feed it into this engine, train it on them, and then take pictures of the crowd to maybe find them in a crowd. That might be a really nice application of this. Let's look at the code. Right here, here's my web page, and I've just got a bunch of buttons on here somewhere. Right, yeah, a bunch of buttons that do test photo and identify faces. And then in my script, I've got code. When you click these buttons, it does something like, way up at the top. Let's go to the top here. Come on. There's my face URL. They all start with the same part of this face URL. This one happened to be in the South Central US, but that URL right there, /face/v10, and that'll always be the start of any web service I call. And if I want to do like, here's where I create a new person group right here, I'll pass it in the group ID that there was a text box, remember, that I filled in there. Then it's going to get my subscription key right here. I've just got that somewhere in a text file. And then the URL is going to be that this URL here, api.cognitivemicrosoft, edit plus /person groups / what I call DG test NDC on there. And then I will put to that URL with the header of my subscription key, and the content type is application JSON, and then there's the JSON itself. I just build that out. And I've done this as a JavaScript promise, so when it comes back, I get the status. I just build up the status back, and when I resolve it, if I look at where it was called from, I think if I do, where is it here? Create group is down here, create group function somewhere here, right here, this is it. So there's where I called it from. Create group ID, and it returns that status, but it returns it asynchronously. So if you're not a JavaScript guy, that's what's going on here. This asynchronously calls this. When it's done, I get the status back, and then I add the status to a label so you see it on screen. I'm the last person in the US that's still using jQuery, but there it is. All right, let's see. So there's the creating a group, and a lot of them are like that. There's also something up here where I wanted to, get a list of all the groups, or if I wanted to delete all the groups, there's a button that does that. And all they're doing, the code is pretty similar here. Add a person to a group. I just get the key here. I figure out the URL. It's that base URL plus something that I get from the documentation, and I get some JSON that I'm going to post in the body. And here it is. I just do a post to a URL. In the header, I pass the subscription key. Content type will be application JSON, and the data itself will be the JSON up above. You'll see this over and over again, and it's done asynchronously, so I'll get something back, some response back, and then I'll either send a status, a success status message or a failure status message, some error message back. That's over and over again. Probably the most complicated one is when you click on adding faces right here. Let me see. Where's my button to add faces? The identify faces in here. This one right here, then I get I look at the picture of the face, and I will call. Let me see. This is this file selector is that thing that actually opens a photograph. And when I do that, I grab the first file in here, and then I just I call this identify faces. So that will call my face service and get all the faces back and all the IDs, and then I just loop through them right here, and for every one, I am going to call the web service that identifies based on my training model who that is, and that's what each one of these is a call to get a face info. If I call F12 right here, that takes me up here, is just calling the web service to identify who that face is and get that information back out and parse out the name. The name is the person's name is what I'm most interested in. Or if it's not a match at all, then I want to know that as well. And that's it. That's the whole thing. This is a nice, clean, simple interface that I guess I've closed it here. I didn't mean to do that. I mean, maybe I could do a little CSS and make that a little pretty, but this is pretty powerful. Just a few web service calls, and I have trained this thing without really doing any of the hard machine learning. I didn't have to learn TensorFlow. I didn't have to write any Python script or anything like that. A lot of the hard part is being done for me. I can build this thing up myself. I will pause right here because this is the facial recognition part. And I'll pause for questions before I go on to the custom image recognition part. But there are no questions. All right, so I'm going to move on. I only have an hour. Yes, sir. Right here.
Can you recognize a full body?
Can you recognize a full body? This API only looks at faces. So if you return if you call an image, you pass a picture, it will return an array of what the faces are in the outline of those faces. Yeah. So this is an issue in computer science all the time. Is if you really want to recognize a full body, let's say you have two people and they differ only by their body type. They have this, they're twin brothers. They look exactly alike, except one's thin and one's heavy. Then that might be a good application of that. Well, this isn't designed for that, but it's really, really simple. If you wanted to build your own application using CNTK or TensorFlow or things like that, you could build that. It'd be more work, but then you could customize it to exactly what you're looking for. Yeah, good question. All right. Let's move on to here. Shift F5. And where am I here? I'm about halfway done. Good. All right. So, come on. Come on. Well, come on. There we go. All right. So the Vision API, this is really similar, except instead of looking at faces, it's more generalized. It can look at anything. Remember I showed you that one service that you call it and said, people waiting at a train station or a man on a skateboard, things like that. It actually returns more information than that, but that's the gist of it. That data that it's looking at is coming mostly from Bing. Bing has a lot of data and a lot of metadata about images because so many people are using it and they're constantly indexing these websites with pictures. But it doesn't have pictures of everything. It has an index. Let's say I have, for example, my own product line that I haven't released to anybody yet, and I have my own jargon to identify that. Maybe I want to be able to identify my own products as they're coming off of an assembly line and have a camera that detects them and then sorts them appropriate. That might be a good way to do it. Maybe I want to have a self-driving vehicle in my backyard, and it recognizes parts of my backyard. This is the corner with the, my kid's swing set. This is the corner. This is the corner with a flower pot, a specific flower pot. I want to recognize those things. So if you want to train it in that way, things that aren't generally known, the custom vision service is the way to do that. So if I want to do this, like here's the simple web service where I just send it an image to a URL. I send a post and it gets back all this information, like what's in the image, what are some keywords. It'll even tell you if it's like dirty pictures. It has a score based on that, which is useful sometimes if you're letting other people upload images to your site. But for custom vision, the steps for doing custom vision are really similar to the steps for doing the custom face recognition. We create an image group before we created a person group, and then we add photos to that image group, and then we tag those photos with some text. And then we train it. So here's a picture of it here. I'll create an image group. This would be, I don't know, my product line, for example. And then I will add a bunch of pictures to it, and then I'll tag each one of those pictures. And the big difference between this and the facial recognition is that you could have overlap. You could have an image that has multiple tags on it. Whereas with facial recognition, there was always a one-to-one relationship between the image and the person. So every image belonged to one and only one person, where this is a many-to-many relationship. But each one of these things is just a web service call, just like it was with facial recognition. And I will show you that right here. So if I go back to here, then actually, no, I don't want to go here. There is, I want to go to this. So I'm going to open up in private window to show you this. It's under custom vision.ai. There we go. Actually, you can get to it from here on images. If I go back to the vision page, down here, there's the custom vision. That will also get to it as well. But I come in here, I sign in, and I'm using an in private window because I have a different account for this one. And I totally agree with whatever that says right there. And from here, I can create, there's my custom vision homepage. If I want to create a brand new project, it's really simple. I give it a name, whatever. I can describe, that's optional. I can tell it, do I want to do, you can give it hints. Is it food? Is it landmarks? Is it retail? I'm not sure what adult is. I'm afraid to click that one. But I think on mine, I just use general right here. And I've done that. I'll just click create project. Well, I'll create it right here. NDC Oslo demo, how about that? And I'll create that. And once I create it, then I can start adding pictures to it. So click on add images. There is a web service that'll do this, but that's all this web page is doing is it's a nice, pretty URL. I'll just add pictures of Brian, that's fine. On this, and I'll give tags to it. Brian as a thing. It's really not designed for for people, it's designed for objects. So I do this, I can add images to that. It's that simple. And then when I'm done, I get a bunch of tags, and I click train, and it goes and train that. It looks like you must have at least 5 images. All right, fine, whatever. And I train it. But let me go, I'll show you what's better is I'll show you one that I've already done. So right here, here's one that I pretended like I had a company and we made these 1, 2, 3, 4, 5, these 6 products. So here's product 1. It looks like that, and I took a bunch of pictures of product 1, and there's product 2, it looks like that, and product 3, it looks like that. I don't have a ton of pictures here, but I deliberately picked products that don't look very much like each other, so it's a little bit easier to do. There's product 6, is this right here, and I happen to be wearing product 6 right here, and I've tagged all of these with my SKUs, so the internet doesn't know about these things. First of all, I totally invented this device right here, and I totally invented this device right here, but also I came up with these names because those are internal to my organization. I want to know it's SKU 1, SKU 2, SKU 3, et cetera. And then once I've done that, once I've added those and I've tagged them, then I would click on train. It'll tell me it doesn't want to train anymore because I haven't added any information since the last time I trained it. So there's no new images, but that's all you have to do. And with only about 100 pictures, or it's about 60 pictures, it goes really fast. And once I've done that, there's actually a test page right here where I can give it an image it hasn't seen. I'm going to try to do this right here. So here's my product 6, is it? Let's take a picture of product 6. And I'm a little bit dependent on the Wi-Fi here because I'm using Apple's iCloud to sync to my PC. So I'm hoping that it'll go fast. It'll show up in here really quickly. If not, I took a picture earlier this afternoon. I'll just use that one. All right. These are all pictures I took of Oslo the last 2 days because I've never been here before. Here we go. I think that's it. Yeah, that's it. All right. So there's my picture that I just took of product 3. And what I can do is go to here and say, grab the local file. Just imagine this is something coming off an assembly line and I want to detect, is it product 1 or product 2? If it's product 6, I want to drop it in that box. If it's product 1, it goes in that box, something like that. And there's the picture I just took. Let's see how it is. Looks good, and it'll tell me that it is probability is 98% sure. So it did a really good job of figuring out this is product 6. It's never seen this picture before. I just took it, but it's seen a bunch of pictures of product 6, and that looks similar enough. So I was able to do that without writing any code. Now, if I wanted to, I can recreate this or customize it because every time, like this, clicking this train button, that's just a web service call that you can write your own code to do that, and that's all documented over here in my, where am I here? In this computer vision. If you look at the custom vision and the API, you'll see the exact same things where you can write your own. And if you wanted to just call it, let's say a lot of times what I'll do is I'll use this interface for training it because it's a nice, pretty interface. It's pretty much complete for what I want to do. But then my application, maybe I want to build an iPhone app and have it call out to my web service. Well, to call that's right here under performance, is the prediction URL. I don't know why it's under performance, but it is. And there it is. So if I send it the image, I'm going to send it to that URL. And here's the documentation. In the header, I'll set prediction key to this. I'll set content type to application JSON. I'll set, if you point a URL to it, what I would have done is actually uploaded the binary image. So I set the body to the image file, and the other two are the same. The prediction key to my key, and the content type to this right here. So I can do this through my own applications, just make a web service call. I can do it from Swift or Objective-C for an iPhone, or Java, or Ruby, or Python, or PHP, anything that can make a web service call, this will work on. And in fact, where am I for time? We got about 20 minutes left. Okay, so I'll show you another one that I did. This was for a real project. I was working with a company that tows cars. They were asked, they were called out, and they wanted to, a car's broken down, tow truck driver goes there, and they had a mobile application that said, go to this intersection, this address, and in front of that address is a car, and it is a Toyota Camry. And so they had this information on the phone, but what they want to do is they want to add a little bit more protection. So they asked the drivers to take a picture of the car, and then they would compare it to this model that is predictive model that said, okay, is this really the Cooper Mini that I want to drive? So I uploaded a whole bunch of pictures of Cooper Minis and a whole bunch of pictures of Ford Explorers and a whole bunch of pictures of a Honda Civic, et cetera. So I gave it a bunch of data right here, and then I clicked train. I trained it, and I came up with a predictive model that then I could call from their application. They just were able to call their, I don't want to do that. I clicked the wrong thing, sorry. Performance, that's what I want. Prediction URL. So right here, they want to just call this URL and pass in an image that they took on their phone. And then get back some information to say, you know, I'm 75% sure that is in fact a Cooper Mini, but it says you're supposed to be towing a Ford Mustang. Don't tow that car. Give them a little extra check on what they're doing. And so that's what I did. And that works pretty well. Let me see if I can, I don't know if I have a picture of a car to test on this. I'll tell you, I'll just go out to the web here somewhere and find a Cooper Mini. Images. I might get a picture that's already in my data set, which is kind of cheating. But let's see, we'll grab that picture right here. And copy it, if it's really there. There it is. So there really is a picture here. And if I go back to here, let's not, oh, I don't want, we could paste in the URL. Let's see if that works. So here's a picture. And it says, oh, it's 99% sure. That's so high, this was probably in my training set. So I probably cheated on this one. That's the idea, is that you get a picture of the car and it would tell you with some reliability which one of these, I think I have 50 different cars in here that I trained on. Each one has about 150 images, I think, something like that, which was a challenge. Finding 150 images of every car. You know, the more pictures I have, the better I'm gonna be. And the way I met this challenge is I wrote an application right here. It's a little console app. And what I did was I got a list of, I found the top 50 most popular cars, at least the most popular in America. And this is right here. I think I just went by Blue Book search. So the 50 most searched cars on bluebook.com. That's what I did. And so in here, there's or I think it's 25, whatever, however many I had. I did that, and I looped through them, and then I have this, once I have this list of car models, then I loop through every one in the list, and I have, let me show you here, this code right here, which is gonna call a web service, and one of the cognitive services is a Bing API search. So you can use cognitive services to do Bing searches. You can search for news or web content or images, and I used it to search for images. And I just looked at the documentation here, and this is a simple web service call that this code I may or may not have copied and pasted out of the help pages for the cognitive services. But yeah, I have a subscription key and built up a URL. A lot of that information is here in the query string. And this is how you call in C#. That's how you call a web service. And I got this information back, and it comes back as JSON. And once I have that, then I would loop through this JSON file, and I would download all of these images. The JSON file would have a bunch of links to images of whatever car, Cooper Mini or Ford Mustang, whatever car I was searching for. And then I would store it here in this folder right here. I have some parameters. So I've modularized this a little bit because I want to be able to customize where the folder is going to be and what to name the files and how many images to download and stuff like that. So right now, just for test purposes, let me run this right here. I'll set a breakpoint here. So I said I want just the 10 most popular car. I don't want all of them. And when I download them, I only want to download 5 pictures of each car. That's because when I run the whole thing, I get hundreds of pictures, and it takes hours to run the whole thing. But it has some output here. There's what is this? I call it car 1, car 2, car 3. It starts with a Honda CR-V and then a Honda Civic. It just downloads 5 images of each car. And if you ever see it pausing for a second, that means that Bing found, there was some result in Bing that it couldn't find on the web, because Bing caches results. Sometimes it'll index something, and then the actual image itself will be gone. So this goes pretty quickly, but while it's running, I'll show you the output of it. Right, what did I say? C/test/cars. And here they are. So like the Honda CR-V is right here. There's those 5 images right here, and just downloaded these things. And the way I did, I could have used one of the custom vision APIs to say, once I have the image, go ahead and upload it and make it part of my predictive model, because there's a web service that will let me do that. But I didn't, and the reason I did not is because sometimes when you call these, when you search on Bing, you get an imperfect result. I don't see an example of it here, but sometimes I might get 2 cars. Like one of them might be, in this case, this is, I think, a Honda Accord. Maybe I'll get a Honda Accord and I'll get a Toyota Camry. Maybe they're 2 different cars, and the advertiser put them side by side just to show a comparison. Well, that's not what I want. I don't want to train on a picture of a Camry. Or sometimes I'll get a picture of a steering wheel, or I'll get a picture of a guy with a T-shirt that says Honda Accord on, or something like that. So you'll get some images that don't make any sense. And so what I ended up doing was, once I had these about 1,500 images or so, then I would go through them manually, one by one. I don't know another way of doing this. I'd say, that's a good image, that's a good image, that's not a good image, I'll delete that image. I would manually clean that up. So I could have done that after I uploaded it here. I could have gone through it this way, but I found it easier to do it locally. But the point is that I did have to do that, which is, if you've done any machine learning at all, you guys that raised your hands originally, you'll know this, is that a lot of your time is spent cleaning up your data. And that's a good example of this here. I had a nice automated way, just go out to Bing, do a search, bring it all down, and I thought I had the problem solved, and I realized that the data's imperfect. It's got some flaws in it, and it wasn't gonna meet my needs completely. I had to do some cleaning up, and a lot of it had to be manual. So this is really, when you're doing machine learning, that's where you spend a lot of your time. This process, it helps that a little bit, doesn't really help that a lot. You still have to look at your data. You have to figure out what it is and get it in the format that you want, and you have to decide what that format is. But it does help with the training. This is code that you don't have to write, which I think is pretty cool. All right, is that done running? That is done running. So I did it for a real small subset of that. But this was my test data. When I was done, I think I had 50 cars there, 50 folders here, one for each car, and then each one of them had like 150 or 200 images, something like that. And then I could come in here and just upload them one at a time, or I never did this. I guess if I was really clever, I would have written a script that after I've cleaned it up, then call the URL to post those images and tag them automatically. Let's see. Oh, the last thing I wanted to show you is, I've been talking about web services a lot, because that's nice and simple. You want to do a quick test, you just go find a picture of, now I can do it. I have a picture here of a Ford F-150, like there. So I can just grab this picture right here and call it, and make a web service, and 91%, that's pretty good. But the disadvantage of this is I have to be online to make a web service call. So that can be a challenge. If I wanted to build a mobile application and I might be going to an area where I don't have good cell coverage, then that means I can't use my application. But there's a way around that. In here, what you can do, let's see, I don't have it for this one, but for my company products, I think it's on the performance tab. Yeah, right here. I can export this. And I can export it in a bunch of different models, as TensorFlow or Windows ML, or export a Docker file for either Windows or for Linux or Core ML. All of these things here are ways of exporting a model that you can use. So if I wanted to export a TensorFlow application right here, I could just download that application, and what is it, about 3 megabytes, so hopefully it doesn't take very long. What do you want to do? Oh, I want to save it. Do that. Come in here, and it's finished. Open the folder, and there's my TensorFlow application right here. And if I want to do it, there's a README file that helps out a little bit here, but really, what I want to do is go back to here, and each one of these there's documentation on how to use TensorFlow, which is good. I actually sat in a session earlier that Seth Juarez did, which was really good. And right here's some sample code. So there's a sample project out on GitHub, which would be a good starter project for using this file right here. This sample project, we'll call it. I think this is an Android project. How can I tell? If I go into the app. So there's code in here if you want to do that. And then this doesn't require a web service call. It doesn't require an internet access or access to the internet at all. Everything is done locally. It builds the model using TensorFlow, and once you have that, then you can just call it from your local application. So this is a lot faster. Depending on what platform you're using, you can export it into a number of different ways. And this is available when I created a new one here. I didn't really show this, but if I go back to my home page in a new project, down here at the bottom, there were options that say compact. Anything with compact means it's available to export when you're done. So that's a big advantage right there. Okay. I have one slide left. And these are just a bunch of links here. This is the slide. Actually, you only need the first link because it's a link to the slides, which has this slide in it. All the code that I've shown is on my GitHub repository. You can take a look at that. This is cognitive services right here. What I remember, I should write this down, is https:/microsoft.com/cognitive. That actually gets you there, right here. And this is my blog. I write about a lot of things, including cognitive services, so go ahead and check that out. And with 8 minutes left, I have some time for questions, but this is the part where I say thank you, and you guys clap. All right, thank you. Questions right here. Yes, sir.
Yes, for the custom mode, can it actually detect two different cars?
Can I detect two different cars? Yeah, it can detect whatever you train it to detect. So it's, actually, you know what? There's a just released, and it's in preview right now. There is image detection, which will detect parts of an image and give you an outlining box around that. The one that I was using when I set this all up, it was one image at a time. So if you trained it with a bunch of pictures of two cars, yes, it would recognize two cars. But if you trained it with pictures of a Ford F-150 and a Cooper Mini, it wouldn't recognize the two of those in the same picture. Now, theoretically, it will. I haven't really played with that yet. That's a new thing that's in preview right now. Yeah. Go the first row there.
So if you have uploaded a lot of pictures
Uh-huh.
of the watch, but why does it use the watch and not, for example, the material of the table or something like this? So can you specify what it should train at?
So we're talking right now about this right here. Is that right?
We had the watch.
The watch, yes. So I had in here originally, so here's my watch right here. And what I did was I said add images, and I took a bunch of pictures of my watch and uploaded them. And then at the end, when I was done uploading, it asked me to tag them. I tagged them all as P06.
Yeah, but why did it recognize the watch and not maybe the material on this the stone or?
It's just smart enough to recognize patterns in this. So this looked a lot more like a watch than the background. The background it decided was insignificant. I guess this would be, the question is, why did it recognize that even though this has kind of a marble background, because I took it in my hotel room, and here I've got a real, vinyl, very light colored background with no texture to it. And it was smart enough to recognize, that's just background material, that this is the real topic of the.
Okay, so if you have a picture of marble with something else, will it be recognized?
You have to test that out. I think if you had a really busy, let's say you put it on, I don't know, a piece of wallpaper, or you put it on top of a painting, then it might take the painting as the significant thing. So I don't really have access to the underlying algorithm, but my guess is it looked at this and said, you know what, this part back here, this is not important. This dark part here is the important part of it. So a lot of the image recognition is smart enough to recognize the actual subject versus the kind of peripheral, metadata about that. And so it's probably ignoring all this background here. Whereas if I put it on, like, let's say I'd taken this watch and set it on top of a photograph of a can of root beer, then it might be confused. It might think that that photograph was meaningful. Yeah, behind you.
I am a developer who working for people with disabilities.
Yes.
Let's assume I want to make an application. You know, people with Down syndrome,
Yeah.
they have specific characteristics on their face. And let's assume I want to make an application to see if someone with Down syndrome is happy or not. I think the normal face API component of services would not recognize because there are people with Down syndrome, there's a significant difference in the face. What's the best way to learn about the happiness indication of people with Down syndrome? Is this custom vision or is this modifying custom vision, just a vision API, but trained with the set of all people with Down syndrome?
Yeah, so I love the way you're thinking here, because this is, I mean, what I'm doing, I don't expect you to build an application that recognizes watches and Coke cans. What I'm hoping is that somebody will be thinking, their wheels will be turning and thinking, I could use this for something to make the world a better place, which is exactly what you're doing. So talk for that. It's hard to say whether this technology would be good enough to recognize everybody's emotions. There is an API for recognizing emotion. It's much, much simpler than what I showed here. You just send an image and it returns a score that says this person is 82% happy and only 3% sad and 2% angry. And that's, people have used that. They showed it Build 2 years ago, a video of something very similar to that.
I know this demo would it work for people with Down syndrome?
With people that what?
I know this demo, but would it work for people with Down syndrome?
Oh, with Down syndrome. Oh, I don't know. I've never tested that. That's a good question. I actually don't know the answer to that. You'd have to test it. So if you have to have a pretty good sampling size to really test it, which is kind of hard to do.
And is the best way custom vision or just the face API? Specific people.
So they say, what's the best? And whenever somebody asks that, the answer is, it depends. That's the answer. It's always the answer. I always start with the simplest. And the simplest in this case is the face API that just returns emotions. See if that works. If it doesn't work, probably the next simplest would be the custom vision API, which may or not be specific enough or precise enough to do what you're doing. And the next best one, or probably the most one you have most control over, would be to writing your own machine learning algorithm. You could use like WinML or TensorFlow or CNTK to do that. That's a lot more work, of course. So I always start with the simplest one and then move backwards from there. Yeah, way over here.
Every new project you create in this application system vision has to be trained from scratch, or is there any kind of common starting point?
Oh, the question is there a starting point for this right here, for these projects?
Yes.
Oh yeah, the only starting points were right here. I'll show them to you again. When I create one, it asks me for broad categories. Like, I guess I have to put a name in first. Come on. Well, it did,
You can identify it
yeah.
without training.
It had like broad categories like food and general, and I forgot what the other ones were. But there's some broad categories like that. There isn't one. I'm not aware of anything that it just has like images already added to it. Is that what you're asking? Are you asking if there's a project that already has images added to it?
Not with image, but with the knowledge base behind it.
Oh, I don't think so, other than those broad categories. I might have lost my internet connection here because suddenly everything's gone. But it was on here. There were some broad categories here that said things like, I remember food was one, and general was one, and adult was one. I'm actually curious what that adult is. If it's those are categorizing by Bing search. Yeah.
You can do image search on there. They can do reverse image search through it.
Okay. All right. Yeah.
Does it work with videos?
Does it work with videos? This doesn't work with videos, but there are some cognitive services that do work with videos, and I'll briefly show it to you right down here. right here. So it'll do things like keywords at different points in the video. It'll create what's called a thumbnail of a video. It'll figure out what the most important parts of it are and squish it down from a 10-minute video to a 1-minute video. It'll do a lot of the same things that vision recognition will do. It'll even do motion detection. If you wanted to set up a camera all night, it'll tell you at what point that it changed. And what's the other one? There's a page that analyzes videos that uses a lot of that. It's got a nice user interface, but I forgot the URL of it. It's like something.ai, vision.ai. Maybe it's computervision.ai. But there's one where it'll analyze a video. You just give it a video. It does things like creates closed captioning, finds all the people in it, and things like that. And I forgot where that is. It's obviously not that URL. But there's a really nice URL for that. It might be on this page right here. If I go back to this. Video indexer. There's the video indexer. Yeah, it might be in here. Video indexer, custom video content. Face detection in video. Yeah, this right here. This is all right here. It'll do emotion detection, so you can see at what point in the video people are smiling and so on. This is a really nice one. And it's sort of an abstraction layer. It's under the hood calling a bunch of other things. An abstraction layer in the sense that this is an abstraction layer, a nice pretty face on those services. Was there another question over here? Yeah, way up here. I'm sorry, I can't hear you.
What do you do if you're not satisfied with the performance of the application?
The question was, what do you do if you're not satisfied with the performance? And I have to ask, do you mean my performance today during this presentation? If you're not satisfied, you want to put the green card in. So the question is, no, I haven't. I'm being silly. I'm sorry. I'm losing points. Yeah, so if you're not satisfied with the performance, there isn't a way. So if you're building your own machine learning model, then you can tweak the model. You can use different algorithms, and there's options to do that. This doesn't really have that. You basically get the algorithm they give you. But what you can do is you can change your data. Is probably your best bet. So it may be that you don't have enough data. The more data, typically the more data you have, the better your model is going to be. And then also you want to have specific data. Like I said, I wanted to train this on cars, and I would get pictures of steering wheels, which is going to skew it. I don't want it to recognize a steering wheel. It's going to be confused. I want it to recognize only cars. If I wanted to get even better, I'd probably have more data that said, show me every make, model, and year of a car. So like a Ford Mustang, they've been making those for 50 years. I would want to have 50 different tags for those, and then my model would be way better in that case. So right now, given these tools, probably the amount of data and the quality of the data is how you can improve your results. Yeah. Okay. Chase, yeah.
So since you can download this, does it just charge you for the training, or?
This is free, actually. It doesn't charge you for anything. I think it's still in preview, though. I'm not sure. There'll probably be some pricing model
It's a fair price.
that's going. Yeah. I think I imagine that it won't be free forever, but I think it's free right now. And I don't know what the pricing model is going to be.
It's all right.
Yeah.
I'll take the free for right now.
Yeah. Again, I said before, start with the simple and then go to the complicated. I have a similar rule: start with the free, and then go to the expensive. Then go to the cheap, and then the expensive. So. Okay. All right, we're a little bit past time, and I really appreciate your time sticking around in the last session of the day. So my name is David. Please throw a green card in. I'd appreciate that, too. Thank you.